Hello, welcome back to Social Data Analysis. I'm so excited about this part of beginner lessons in R because we're getting to the point where we can analyze big data. Today we'll be talking about data frames. Previously, we spoke about matrices. We said matrices were table-like data structures, but matrices could only contain only one data type, right? Either Boolean or logical, string or character, numerical or integers, right? But with data frames, you can have mixed data types. Data frames work like spreadsheets in Microsoft Excel. You have your columns, which could contain any type of data, and then you have your rows, which are the number of observations that you are looking at. It's exactly the same thing that we are going to look at in R. Now, data frames are important because they are very easy to manipulate, clean, and do analysis. It's also very good for doing data visualizations. Most of the data you see out there are in data frames, so it's very important that you know how to use data frames. In this lesson, I'm going to give you the introduction to data frames, and in the next lesson, we're going to do some advanced manipulations with data frames and do some advanced analysis. Later on, I'll introduce you to tidyverse, where we can use dplyr, one of the tidyverse packages for data manipulations. And later on, we use ggplot2 for data visualizations. For now, I want to introduce you to data frames and help you get a grasp of how to do some basic manipulations in data frames using R. See you in the lesson. All right, so let's get into the lesson. Now, a typical name of data frames in the real world is data sets. So I would want to use the term data sets instead of data frames, right? So if I use data frames or data sets, no, I'm talking about the same thing. Now, there's a popular data set in R that you can use to practice how to analyze data, and I'm going to introduce you to it. So I would recommend that in this particular lesson, you code alongside with me and we move along together, right? Let's load a data set called mtcars in R. So go to your R studio and key in mtcars. If you key in mtcars and you run it, you're going to have this data. Function in R that is always helpful to start with when you want to explore data sets. It's called head. So the head function helps you to extract the first few columns of a data set, and you get to check out what the data set is about. Let's run head on empty cars, and what you have is the first 6 observations of the empty cars data set. So if you look inside the output column, you have different types of cars and their various mile per gallon and all the other data that you have here. We have horsepower, we have the weight of the car and things like that. So that is what head does. Equally, you could also do tail, right? And tail will give you the last few observations of this data set. So it's a good way to start, getting to know your data. We could also look at a function called str, and what str does is that it helps us to learn about the structure of the mtcars dataset. Let's check what str does when we put in mtcars. str helps us learn more about the data types in your data set. When we called str, we're able to learn that all these columns are numerical data types, and if it was string or boolean or whatever, we can learn about it using str. Now str is good because knowing the data type of your column helps you do proper analysis, because as I mentioned in previous lesson, you cannot do an analysis on a data type that you do not know, right? You're gonna get wrong results. Now let's go in deeper. Let's start doing some manipulations on this data set. Remember that when we were learning vectors, matrices, we were able to select specific parts of our data using the double squared bracket. We can do the same thing when we are dealing with data sets or data frames. So look at the code that I have here on line 15. I created an object called selected data. I called my data set mtcars, just like I would have called the name of any vector or matrix. And then I brought in my squared bracket. Now, when I brought in my squared bracket, I brought a comma. What it means is that I am interested in all the rows of this data set. I'm not interested in selecting from any particular rows. So leaving the row section blank or putting nothing in this side of the data means that I'm interested in all the rows. But in the column section of our squared bracket, I'm interested in the MPG, the cylinder, and the horsepower columns of our data set. But what I do is I use the combine function to put together these three columns that I want to subset from our data set. Then I use it in my squared bracket to select out these three columns. Now, when I call selected data using the head function to know the first few observations, what I get is a new data set called selected data that has only these three columns. So I have selected out these three columns. I am just interested in using these three columns for my analysis. I don't want to use the other columns, so I want to shrink my data to the columns I'm interested in. And that is how I do it, right? Again, if I was interested in only a couple of observations, I could have specified those observations before the comma sign. But because I'm not interested in anything like that, I left that part blank. So this is how you can select just a portion of the whole data that you are interested in and work with it. You don't have to see a lot of data and then you are scared, you don't know where to start from, whilst you are only interested in just a little bit of it. Now, just as we selected on columns, we can also select on the rows that we are interested in. Now, assuming I'm interested in some type of observation. For example, I'm interested in cars that have 6 cylinders only, exactly 6 cylinders. I can use the same approach to filter out only observations that have 6 cylinders. So look at the code on line 19. I created a new object called filtered data and I assigned to it starting from calling my data set. I brought in my squared bracket, which is what I use for my subsets. And then I said, call mtcars dataset column cylinder. So if you want to select a particular column from a data set inside a square bracket, you use the $sign to call only that particular column for that data set. And this is what this line of code here means: mtcars $cylinder. And then I use the double equal sign to say I am only interested in observations that has cylinder equal to 6. I am only interested in observations that has cylinder equal to 6. Now, because I'm only interested in observations, in other words, only rows, I leave the column part blank. So you realize that after the comma sign here, I have nothing I have nothing after the comma sign, showing that I want all the columns in my data set for which the cylinder has a value of 6. Now let's run this code and see what we get. Now, what we have here is a subset of our data, everything in our data set that has cylinder equals to 6. So in other words, every car we have here has 6 cylinders inside it. And I have all the columns because I did not specify the columns I want. I only specified the rows I want. And I said the rows I wanted were rows for which the cylinder column is equal to 6. Also, we can rearrange our data. We can order our data set by a specific rule that gives us an arrangement of observations or rows that makes us happy. Let's look at this line of code on line 23. Now, I created an object called arranged data and I assigned to it this particular information. I said, I want the data set called mtcars. I called mtcars. I brought in my squared bracket because I want to perform some filtering or some arranging or some sort of manipulation on my data set. And then I called a function called order. Now, what this order function does, as the name goes, is it orders your data set by some rules that you specify it. Now, the order function has two very important arguments. The first argument is the order function will tell you, okay, what data set do you want to. Now, the order function has two very important arguments. The order function asks you, okay, what column in the mtcars data set do you want to order your data by? Over here, I said, I want to order my data by the mpg column of the mtcars data set. So that is what I mean by writing mtcars $mpg. It means that select out the mpg column of the mtcars data set. That is what I want to order my data by. Now, the second argument is, do you want it in ascending order or descending order? By writing decreasing equals true, I am saying that I want you to order my data set in descending order by the values of the mpg column in the mtcars data set. It's as simple as that. Once again, I am only interested in observations and not columns. I am only ordering the observation of the rows in my data set. So you realize that everything I have here comes before my comma sign because I am referring to a manipulation on rows or observation. But after the comma sign, everything is blank because I am not ordering or rearranging my columns. I am only ordering or rearranging my rows of observation based on a function called order and doing it using the mpg column of the mtcars dataset. So when we run this code, what do we get? We get a newly arranged data set that has a new ordering by descending order of the mpg column. So if you look at the mpg column, which is the first column in our data set, you see 33.9, 32.4 downwards. What it tells you that your data set has been rearranged based on a particular column. Now, this can be very meaningful to you. For example, if you were doing some analysis and then this column was the most important column for you based on your theory or your conceptualization, then you might want to rearrange your data based on that particular column. So this makes total sense. Now, remember, we are still using the head function to get a snapshot of the data set. So the whole mtcars data set is so big, and anything we do, I introduce the head function because it gives you a snapshot of the entire data set or the entire results. Now, after you've done this manipulation, you could use any of this data for anything you want. For example, if you were really interested in the filtered data based on cylinder equals 6, you could use the data set called filtered data because that is the version of the manipulation that gives you your empty cars cylinder column equal to 6. If you are interested in the data set that has been arranged using the mpg column, you're going to go further with your analysis using the data set called arranged data because that is the new version that you've created in terms of the arrangement that you want. So I'm going to go ahead and do my analysis from now using arranged data because that is the version I want. I'm interested in something that is ordered using mtcars mpg column. Now my boss tells me he's interested in the fraction of the weight of automobiles and the horsepower of the automobile. In other words, what do we get when we divide the weight of an automobile divided by its horsepower? And my boss doesn't want to do this calculation every time. He wants a column that does this calculation automatically. I can go ahead and create this column inside my data set that has this fraction for my boss. Check out this line of code on line 29. Now, this is how you create a column inside an already existing data set. I have my mtcars data and I create a new column called weight per HP. So it has weight underscore per HP. Now with the dollar sign has a lot of usefulness in R. With a dollar sign, I am able to insert this new column I am creating inside an already existing data set. So the empty cars an already existing data set. I'm creating a new column called weight per HP, and I'm making weight underscore per underscore HP belong to an already existing empty cars data set. Now the whole thing here is going to be the object that I am creating, because that is going to be the new data set which I am going to be using henceforth. Therefore, it is serving as the object, and then I am assigning to it the fraction that I'm talking about. And what is this fraction? The fraction is I want the weight of the car divided by the car's horsepower. So again, I use my dollar sign to extract the weight column of the empty cars dataset divided by the horsepower column of the empty cars dataset. What I get is assigned to a new object, which is the empty cars dataset with a new column called weight per HP. This is so useful because I'm able to create a new column for my boss that gives the fraction of weight divided by horsepower. And I run it, check it out in the last column here. So my boss has this information handy anytime he wants to use it. I can also go ahead and do some basic descriptive statistics, right? What is basic descriptive statistics without checking out the average or the mean and then the max of your data? Now let's check out the code on line 33. I'm interested in the mean of the mile per gallon column of my empty car data set. What is the average? My boss asked me, what is the average of all these cars mile per gallon? What is the average? What does it mean? And then I said, okay, well, I can find that out by doing line 33. And what it gives me, if I call mean MPG, is 20.09062. So the average mile per gallon of this data set or of these observations is 20.09. I have the figure. It's that simple. On line 34, my boss is asking me to find out the maximum horsepower of these cars, the maximum horsepower. On line 34, I'm able to find out the maximum horsepower. If I call max HP, which is the name I gave to my object, it should give me the value of the maximum horsepower. This data set has the maximum horsepower of the cars to be 335. Now, before we go, let me show you another very interesting function in R that is going to help you do your analysis. Assuming you were interested in the average or the mean of a particular column based on the figures of another column. Assuming I am interested in the average mile per gallon of the cars in the empty cars dataset. Assuming I am interested in finding the average or the mean mile per gallon of the various number of cylinders in a car. So in our data set, there are three different values for the number of cylinders. and I want to find out that what is the average mile per gallon if the cylinder value is this or that or the other one. Check out this line of code on line 37. On line 37, I want to find out the average mile per gallon of every value that holds different for cylinder. So in other words, I want to use the cylinder, I want to compare different averages for mile per gallon based on the values inside the cylinder column. Now this is quite sort of an intuitive step, right? So I use a new function altogether different from the mean function, and this function is the aggregate function. The aggregate function on line 37 basically has three arguments. The first argument is what is the column that you want to compare? What columns do you want to compare? What column do you want to find the mean of based on the other column? Now I use this tilde sign to show that I want to find out the average of MPG based on the values of cylinder. Now the second argument of the aggregate function is I want the mtcars dataset. So data equals mtcars is I am calling the mtcars dataset as what I am using for this simple analysis. Now what function am I interested in? I'm interested in finding the mean of MPG, and then that is the last argument here. Now let us run this inside a new object called AGG. If we run line 37 and then we call the AGG object, what we get is mean or the average of three different types of. Now when we call the AGG object, what we are getting is in our data set there are three different types of. Now if we run our AGG object, now if we call our AGG object, this information we are getting basically means that in our data we have three different types of cylinders that cars can have. Now when we call our AGG object, this information we have means that in our mtcars dataset we have some cars with 4 cylinders, and the cars with 4 cylinders has an average mile per gallon of 26.66. The cars with 6 cylinders has an average mile per gallon of 19.74, and the cars with 8 cylinders has an average mile per gallon of 15.10. So you see how the aggregate function helps you find the average or the mean of a particular column based on information in another column. It is so cool. It is so cool. So get a hang on these things. You can go back and replay the video, practice along, and get used to these simple data manipulation and data analysis in data frames. With these skills, you can basically pick any data set and try to get to know the data set and what you can do with it. If you haven't subscribed to this YouTube channel yet, please subscribe so I can bring you more content like this. Leave a comment as well. I really appreciate feedback and I want to know how to serve you better. Thanks and see you in the next video. Bye.